Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Class 9 Solutions for Chapter 11 Work and Energy. In-text questions. A force of 7 newtons acts on an object. The displacement is say 8 meters in the direction of the force. Let us take it that the force acts on the object through the displacement. What is the work done in this case? So here given force is 7 newtons, displacement is 8 meters. We know that work done is equals to force into displacement. Putting the values, we get work done 56 Newton meters or 56 joules. When do we say that work is done? Work is said to be done when a force causes displacement of an object in the direction of the applied force. Write an expression for the work done when a force is acting on an object in the direction of its displacement. The expression is work done is equals to force into displacement. Define 1 joule of work. 1 joule is the amount of work done by the force of 1 newton on an object that displaces it through a distance of 1 meter in the direction of applied force. A pair of bullocks exerts a force of 140 newtons on the plough. The field being ploughed is 15 meters long. How much work is done in ploughing the length of the field? Given force 140 newtons, displacement 15 meters. So work done will be force into displacement. Putting the values, we get 100 joule work is done here. What is the kinetic energy of an object? The kinetic energy possessed by a body by the virtue of its motion is called kinetic energy. Every moving object possesses kinetic energy. Write an expression for the kinetic energy of an object. The expression is kinetic energy is equals to half mv square, where m is the mass and v is the velocity of the body. The kinetic energy of an object of mass m moving with the velocity of 5 meter per second is 25 joules. What will be its kinetic energy when its velocity is double, and what will be its kinetic energy when its velocity is increased by 3 times? So kinetic energy is 25 joules, velocity is 5 meter per second. So we know that K is equals to half mv square. So from that we can figure out mass, which is 2 into kinetic energy upon v square. Putting the values, we get mass 2 kgs. If the velocity is doubled, that is 10 meter per second, then kinetic energy will be, putting the values in the formula, we get 100 joules. Similarly, if the velocity is tripled, that is 15 meter per second, then the kinetic energy will be, putting the values, we get 225 joules. What is power? Power is the rate of doing work. If W is the amount of work done in time t, then the power is given by the expression power is equals to work upon time. It is expressed in watts, that is W. Define 1 watt of power. A body is said to have a power of 1 watt if it does work at the rate of 1 joule in 1 second. A lamp consumes 1000 joules of electrical energy in 10 seconds. What is its power? So we know that power is equals to work done upon time. So work done is energy consumed by the lamp, that is 1000 joules. So power will be 1000 upon 10, that is 100 joules per second or watts. Define average power. The average power of an agent may be defined as the total work done by it in total time taken. Back exercises. Look at the activities listed below. Reason out whether or not the work is done in the light of understanding of the term work. A. Suma is swimming in the pond. Now work is done whenever the given two conditions are satisfied. A force acts on the body, and B, there is a displacement of the body by the application of force in or opposite to the direction of the force. So while swimming, Suma applied the force to push the water backwards. Therefore, Suma swim in the forward direction caused by the forward reaction of water. Hence, the force causes displacement. Hence, work is done by Sima. A donkey is carrying a load on its back. While carrying a load, the donkey has to apply a force in the upward direction, but the displacement of the load is in the forward direction. Since the displacement is perpendicular to the force, the work done is 0 here. C. A windmill is lifting water from the well. A windmill works against the gravitational force to lift the water, hence work is done by the windmill in lifting the water from the well. A green plant is carrying out photosynthesis. In this case, there is no displacement of the leaves of the plant, therefore the work done here is 0. An engine is pulling a train. An engine applies force to pull the train. This allows the train to move in the direction of the force. Therefore, there is displacement in the train in the same direction, and work is done by the engine of the train. Food grains are getting dried in the sun. Food grains do not move in the presence of solar energy, hence the work done is 0 during process of food grains getting dried in the sun. A sailboat is moving due to wind energy. Wind energy applies a force on the sailboat to push it in the forward direction. Therefore, there is displacement in the boat in the direction of the force, hence work is done here. An object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and final point of the path of the object lies on the same horizontal line. What is the work done by the force of gravity on the object? So to calculate the work done, there must be displacement, but since in the example, the vertical displacement is 0 as the initial and final positions lies on the same horizontal line. So the work done by the force of gravity is 0 here. A battery lights a bulb. Describe the energy changes involved in the process. Within the electrical cell of the battery, the chemical energy changes into electrical energy. The electrical energy on flowing through the filament of the bulb first changes into heat energy and then into light energy. Certain force acting on a 20-gram mass changes its velocity from 5 to 2 meter per second. Calculate the work done by the force. So the work done by the force is equal to the change in kinetic energy produced in the body. Given mass is 20 grams, initial velocity 5 and final 2 meter per second. Work done is equals to change in kinetic energy, which is half mv square minus half mu square. That can be written as half mv square minus u square. So putting the values, we get work done minus 210 joules. The negative sign indicates that the work has been done in slowing the body. A mass of 10 kilograms is at point A on the table. It is moved to point B. If the line joining A and B is horizontal, what is the work done on the object by gravitational force? Explain your answer. Since the work done on the object by gravitational force depend upon the change in vertical heights of the object, vertical height of the object is not changing here as the line joining A and B is horizontal at same height. Hence the work done is 0. The potential energy of a free falling body decreases progressively. Does this violate the law of conservation of energy, and why? It does not violate the law of conservation of energy, because whatever is decrease in the potential energy due to the loss of height, same is the increase in the kinetic energy due to increase in the velocity of the body. 7th, what is the various energy transformation that occurs when you are riding a bicycle? While riding a bicycle, the muscular energy of the rider gets transformed into heat energy and kinetic energy of the bicycle. Heat energy heats the rider's body and kinetic energy provides velocity to the bicycle. The transformation can be shown as muscular energy changing into kinetic plus heat energy. During the transformation, the total energy remains conserved. 8. Does the transfer of the energy takes place when you push a huge rock with all your might and fail to move it? Where is the energy you spend going? Energy transfer does not take place as no displacement takes place in the direction of the applied force. The energy spent is used to overcome the inertia of rest of the rock. 9th, a certain household has consumed 250 units of energy during a month. How much energy is this in joules? 1 unit is equals to 1 kilowatt hour. 1 kilowatt is equals to 3.6 into 10 to the power 6 joules. Therefore, 250 units will be 250 multiplied by 3.6 into 10 to the power 6, which is equals to 9 into 10 to the power 8 joules. 10th, an object of mass 40 kg is raised to a height of 5 meter above the ground. What is its potential energy if the object is allowed to fall? Find its kinetic energy when it is halfway down. So the potential energy here is mgh, where g is the acceleration due to gravity, which is 10 meter per second square. Now putting the values, we get potential energy 2000 joules. When the object is halfway down, that is height is 2.5 meters, the initial velocity is 0 as thrown from rest. Now since v square is equals to u square plus 2gh, so v square will be equal to 50. Now kinetic energy is half mv square. Putting the values in this equation, we get kinetic energy 1000 joules. 11th, what is the work done by the force of gravity on the satellite moving around the earth? Justify your answer. When a satellite moves around the earth, then at each point of its path, the direction of the force of gravity on the satellite along the radius is perpendicular to the direction of its displacement along the tangent. Hence, the work done on the satellite by the force of gravity is 0. Can there be a displacement of an object in the absence of any force acting on it? Think and discuss. The answer is both yes and no. Yes, because when an object moves in the deep space from one point to another point in the straight line, the displacement takes place without the application of force. And no, because the force is required for the displacement of an object on the surface of the earth. 13. A person holds a bundle of hay over his head for 30 minutes and gets tired. Has he done some work or not? Justify your answer. The person does not do work because no displacement takes place in the direction of the applied force, as the force acts in the vertical upward direction. 14th, an electric heater is rated 1500 watts. How much energy does it use in 10 hours? So we know that power is equals to work upon time. Power here is 1500 watts, that is 1.5 kilowatts. Time is 10 hours. Work done is equals to energy consumed by the heater. So energy consumed is equals to power into time. Putting the values, we get energy is equals to 15 kilowatt hour. 15. Illustrate the law of conservation of energy by discussing the energy changes which occurs when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually comes to rest and what happens to its energy eventually? Is this a violation of law of conservation of energy? When a pendulum moves from its mean position P to either of its extreme positions A or B, it rises to a height h above the main level P. At this point, kinetic energy of the bob changes completely into potential energy. The kinetic energy becomes zero and the bob possesses only potential energy. As it moves towards the point P, its potential energy decreases progressively and accordingly kinetic energy increases. As the bob reaches point P, its potential energy becomes zero and bob possesses only kinetic energy. This process is repeated as long as the pendulum oscillates. The bob does not oscillate forever. It comes to rest because air resistance resists its motion. The pendulum loses kinetic energy to overcome this friction and stop after some time. The law of conservation of energy is not violated because energy lost by the pendulum to overcome the friction is gained by its surroundings. Hence, the total energy of the pendulum and the surrounding system remains conserved. 16. An object of mass m is moving with the constant velocity v. How much work should be done on the object in order to bring the object to rest? In order to bring the object to rest, the work done must be equal to the kinetic energy of the moving object, which is half mv square. 17. Calculate the work required to be done to stop a car of 1500 kilograms moving at a velocity of 60 km per hour. So given mass of the car is 1500 kg, velocity is 16 km per hour. Changing it into meter per second, we multiplied it by 5 by 18. So kinetic energy is equals to half mv square. Putting the values, we get kinetic energy is equals to 20.8 into 10 to the power 4 joules. So this much work is required to stop the car. 18th, in each of the following, a force F is acting on the object of mass m. The direction of the displacement is from west to east as shown by the longer arrow. Observe the diagram carefully and state whether the work done by the force is negative, positive or zero. In case 1, the direction of the force acting on the block is perpendicular to the direction of the displacement. Therefore, the work done by the force on the block will be zero. In case 2, the direction of the force acting on the block and the direction of the displacement is same. Therefore, the work done by the force on the block will be positive. In case 3, the direction of the force acting on the block is opposite to the direction of the displacement. Therefore, the work done by the force on the block will be negative. 19. Sony says that the acceleration in an object could be zero even when several forces are acting on it. Do you agree with her and why? Yes, acceleration in an object could be zero even when several forces are acting on it. This happens when all the forces cancel each other and the net force acting on it, the object is zero. 20. Find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watts each. Now given power rating of each device is 500 watts, that is 0.5 kilowatts. Time for each device is 10 hours. So work done is equals to energy consumed by each device, that will be power into time. Putting the values, we get 5 kilowatt hour. Therefore, energy consumed by 4 devices will be 4 multiplied by 5 kilowatt hour, that is 20 kilowatt hour or 20 units. 21. A free falling object eventually stops on reaching the ground. What happens to its kinetic energy? As the object hits the ground, its kinetic energy gets converted into first heat energy. The object and the ground become slightly warm. Second, sound energy. Sound is heard when the object hits the ground. And third, potential energy. The object and the ground gets deformed a little bit at the point of collision. Thanks for watching. Please do like, share and subscribe.